So for geometric sequence, a little bit different than arithmetic. Arithmetic added a number every single time. Geometric is going to multiply a number every single time. I mean, or it could be dividing, because those are the same thing, really. It could be multiplying by a fraction or dividing by whatever that bottom number is. So sometimes the hard part is to find the ratio. All you do to find the ratio is just take the second number divided by the first number. Okay? That's a little more difficult to figure out. And then here's the formula. Now this formula I'm not going to play around with too much. I could, but I'm not going to. So this formula uses A1, so it does use the first one. And the reason I'm okay with it is because I could give you an A sub 0 formula. And I'll just tell you what it is, in case some of you do like that. So this is A sub 0 times, it's supposed to be 0 times R to the N. But the reason I don't really play around with that too much is it's kind of sometimes difficult to figure out what the previous number would be. Because when we're just like adding or subtracting, it's very easy. You can figure it out what the number 4 is. But when you're multiplying and dividing, it gets a little bit trickier. Like on the first one, it's not trickier because you can tell like the pattern is. But like when you start going by like 7/5, if you're multiplying 7/5 every single time, and you have to go backwards, it's almost more work. So that's why I think it's easier for this one to use A1. You can use either one and you'll be totally fine. But yeah, let's go for it. So this one just says to find the common ratio. So all we need is just find R. So how do we find R for this one? This one's obvious. What does it do every single time? Multiplies by 3. If you're totally lost, you would just do, look at the first two numbers, you would just do 9 divided by 3. Again, this one's kind of obvious, so not a big deal. Look at 2, write the 5 first terms when we have A1 is 3 and then the common ratio is 2. So the easiest thing is to write down our formula and then we can go from there. So what is A1? It's 3. The common ratio is, I always put it in parentheses, 2 to the n minus 1. So by the way, it's totally possible for our signs to alternate. When would that happen? If the R is any type of negative. For common ratio is any negative, it would alternate. So remember how that first day I said you'll get more used to the alternating stuff? Well, that should be happening very, very soon. It has to do with this. So what is A sub 1 if I plug in a 1? Or if I can just read the problem. Either way, it's 3. What's A sub 2? You can plug in a 2 or you can just figure out what the heck the pattern is. What's that, class? You all said 6? That's a fantastic answer. It is 6. A sub 3. You can plug it in to be like, 3 minus 1 is 2. 2 squared is 4 times 3 is 12. At some point, you can just start noticing the pattern. What is the pattern? What? Yeah, just doubling it. Alright. So yeah, there's that. Let's get a little bit harder. So find the 15th term of the geometric sequence whose first term is 21, or is 20. Let me say 21. This is A sub 1 is equal to 20. And whose common ratio is 1.5. Or 0.5, sorry. So the formula is 20, 1.05 to the n minus 1. I want you to find what term? Very good, class, the 15th. Daniela, this is what the class is like without you. I know, right? Wait a minute. That was a dig at me. You know what? Now I'm going to get... So what you do now is you just plug in a 15. You do have a calculator in front of you. What is 1.05 to the 14th power times 20? I don't know it. 39 point what? What story do you want to know? Give me a year, a month, and a day, and I'll tell you a story about what happened on that day. Best Halloween I've ever had? I don't know.
Like, I can't remember.
I can't remember. I don't know. I'm trying to think. The best Halloween I've ever had. Had to have been when I was a kid, because it's okay now. I mean, even though I have kids, but I do just steal their candy, so I guess it's getting better.
I knew parents were annoying.
Okay.
I knew they did that.
Well, okay, my kids are 4 and 2. They're not going to know. I don't want my kids to have candy. Now, when my kids are like 8, 9, 10, I'm probably not going to steal their candy. They will know, especially if the kids have my brain whatsoever, they'll know how many candies they have.
Hey, do you remember sorting your candies out and then, like, trading with people? That was the best part of Halloween.
Trading.
Trading, yes.
Trading.
You get your favorite candy, they get their favorite.
Like, you'd be like, have you seen that one?
So there's a mathematical thing to organize your candies, by the way. So it's called the candy lineup. You line up all of the candy in just random order. And then the first person picks whatever they want the stopping point to be. So let's say that there are 20 candies lined up. So just 20 random candies between 3 people. Seems unfair, right? Because not everyone's going to even them out. But the first person can look at the first, if they want the first 8 candies. I want the first 8. They put their line right there. The next friend, if they want less than 8, they can put their line and then they would get that. Or if everybody's like, nope, that's fine, then that person gets the first 8. Then the next person goes, and there's 12 left. And they can be like, oh, I want the first of that 12, I don't know, 7. And then the next person goes like, nope, I want the 6. So that person who wanted the 6 gets the 6, and that last person gets the rest.
That just sucks. Why would anyone want to do that?
No, it's a fairness thing. So, like, imagine you get a pizza of 8 slices of all different types. Like I hate all pizza except for the pepperoni and just cheese. So, like, if there's like 1 pepperoni, then to me, my fairness is I want that pepperoni. I don't want 2 slices of something else. I value my 1 pepperoni more than I value 2 of anything else. I know it's on the video. It's math related. So yeah, that is fair. So with the candy lineup, it's fairness because maybe the first 4 are $100 grand, and again, it's random. I would value those first 4 and could care less if I got 7 candies that were okay versus the 4 that I absolutely value. So yeah, that's my Halloween story. I've never done that before in my entire life, but that's just how fairness works. 100 grand. Whenever I get 100 grand, I'm so happy. Well, I don't because I buy the bag that has them, and then I take the ones that take them out. Granted, this year I didn't do that. I'm trying not to eat so much candy this year. I'm trying to lose weight. And I think if you go to every single video that I have on Halloween for the past 5 years, I probably say the exact same thing. I'm trying to lose weight this year. I'm sure. Not going to eat that much candy. Hey, but leading up to Halloween, I've done better this year than any other year. Because usually I buy like a bag on like October 1st when they first show up. And then by the time Halloween comes around, I'm like, oh man, I need to buy more candy. But this year it didn't happen. I didn't buy any candy until Friday last week. I got 450 pieces. It's a lot of candy. 450. But they're tiny. They're like little ones. I don't know. Well, and the thing too is at my house, I'm not home to do anything because I'm with my kids. So I have to pull it out in the bowl and I have to write like take 1. I know.
You know, I would never take 1 because I always need to have cameras watching me. No, I also took the bowl with me.
I think with 450, maybe I'll say take 2. I don't know. I have a pretty big bowl. I'm probably gonna have 100 in the bowl at a time. Okay, all right. Now that we're more interested in math, let's move on. All right. So find the 9th term of the geometric sequence. Why don't you try this one on your own? Can't you do this one on your own? It's no different than the one we just did. So try it on your own. While you're doing that, then you can talk about candy with your group. Daniela, what's your second favorite candy? Mine's cookies and cream. Hershey's cookies and cream, the white chocolate. That's good.
I don't know.
Again, you never get that. That's a rare one.
You know the worst type of people are the ones that like
The Almond Joy people?
No, Almond Joy.
Ah!
No, the people that eat Almond Joy What's wrong with you? White chocolate is like nasty. Why do people eat that? That's gross.
Ah.
Like, when I was like eating a chocolate bar by itself, I love that. No, I need stuff in it.
Oh, there's another one that's terrible too. It's got like coconut in it.
Whoppers. Whoppers are great.
Not a fan of Whoppers.
I love Whoppers. I like Whoppers.
I forgot what it is, but there's another one that.
Oh, Mounds.
No, yeah, Mounds. I hate Mounds.
Oh my God, Mounds.
It's terrible. All right, if I get any Mounds, I'll bring all the Mounds in. Too bad you're not here tomorrow. We walk by my room, just ask for Mounds. Yeah, just ask for Mounds. All right, what do we get? Anybody get an answer here, or we just kept talking about Mounds?
We got it. 0.016.
0.016? Cool. Let's keep on going. Oh, there's a lot of stuff on here for not supposed to take so long. Should stop telling stories because we only got like 17 minutes left. Actually, now I know my favorite Halloween memory. Okay, so the next problem. I don't care. I hate that candy. Well, my one son is allergic to peanut butter, so that's an easy take. Alright. Butterfingers, Reese's Pieces. Is it Reese's Pieces or Reese's Pieces?
I hate Reese's.
I like them. Yeah, someone had them in last class, right? Yeah, you did. Oh, they're so good. Peanut butter cup. Oh man, it's so good.
I like Reese's. White chocolate Reese's.
Alright. So for this one right here.
White chocolate.
My fault. What's the first term? It's 5. How much am I increasing by each time? I'm multiplying here by how much? So, a sub n is going to be equal to 5 times 3 to the n minus 1, right? That looks terrible, but you get the idea. So if I want a sub 12, I'm going to get 5 times 3 to the 12 minus 1. I do need help again. I don't have the calculator in front of me. How big is this big number? 885. I'm going to trust you. Okay. Okay. Try 6 on your own. It's a little bit tougher. Try 6 on your own. Again, if you cannot figure out how to find R, what do? You cry. What do? I said it already. So what do? Second number divided by the first number. Because this one's a little bit tougher to figure out. Who got an answer for me? It's a really, really tiny number. It should be negative, right? 3.04 times. Cool. Alright, so now we're going to start giving you different pieces of this information. So the fourth term of a sequence is 125, and the 10th term is this right here. Find the 14th term if all of the terms are positive. So this one's a little bit tougher. Okay, so let's go ahead and use our formula. What do I know about this formula? Well, I don't know R. How can I find R? Just figure it out. Any ideas? Slope, kind of. It's the right idea. kind of, sort of. Like, that's one idea. Daniel, what were you saying? Sounded good, because you said plug it in.
So I did A10 equals A4.
You did A sub 10?
A sub 10 equals A sub 4 times R to the 6.
Why'd you do that?
Because I knew it multiplied 6 times between A4 and A10. And then if I plug in the value,
Times R to the 6. So what happens? You're going to get 1 over 64. Okay, you have a calculator for this. So don't be too scared. 1 over 64 equals R to the 6th. So in your calculator, do you know how to do the 1/6 power? So to get rid of this 6, you actually have to do on both sides the 1/6 power. What is 1 over 64 to the 1/6 power? It's 1/2. Okay, this is like exponents, right? How do you get rid of a squared? You square root it. How do you get rid of a 6? Or, yeah, a 6. You 6th root it. How do you 6th root something? Number 1? Okay. Alright, because, so there's a difference of 6. It's kind of like the slope. I like how you moved up. Hey, I write as large as the space that I'm given. Okay. Want me to put this in a slightly different formula? Very slightly different formula. So this one would be, it's like slope. This is the formula we want to use. This is just me applying it. Okay? So you take the 10th divided by, because usually to find the ratio, we just do the second divided by the first. But this one, we have the 10th divided by the 4th, and R is going to be 10 minus 4. So this is what we can use here. Okay? I'll just figure out R. Okay, did that clear things up a little bit? Okay. In this part right here, you really need to know. Oh, we're all moving closer now. It's a nice blanket. So we're going to get R to the 1/2. Once we have that, find the 14th term. Well, do I have the first term yet? No. So A sub n equals A sub 1, 1/2 to the n minus 1. How can I find A sub 1? Just plug in one of these. Which one's easiest to plug in? Probably the 4th one. Right? So A sub 4 is how much? 125 equals A sub 1, 1/2 to the 4 minus 1. So I want to do that math for me. What's 1/2 to the, well, okay, I can do that math. It's 1/2 to the 3rd, which is 1/8. You got to do 125 divided by 1/8. And you're going to get, is it 1,000? You get 1,000, so A sub 1 equals 1,000. I'm going to continue the work down here. So A sub n is equal to 1,000, 1/2 to the n minus 1. And now you're going to plug. We're going to plug in 14. So A sub 14 is equal to 1,000, 1/2 to the 14 minus 1. Somebody's going to help me out here. 0.12? That's not bad. So 0.12. So number 8's just like that one, right? Second term, and they got the 5th term, find the 6th term. Try number 8. It's just like that one. I correct? So all this work over here was to figure out what R was. All this work right here was to figure out what A1 was. So this geometric stuff takes a little more work. What is it? So all the way through. So when we plug in A6, you're going to get 54 times negative 1/3 to the 5th. So it'll be 6 minus 1. And we get negative 2/9. Is that correct? 2.222222. It's 2/9. If you write 0.222, it's not going to bother me whatsoever. I mean, I'll die a little on the inside. Not, I mean, like, they don't even know what fraction that is, but whatever. Alright, we good? No? When we start getting into the sums, it gets a little bit easier. So I think it's coming up. Sums, right? Yeah, sums. Alright, flipping it over. Okay, formula. You gotta memorize this one. Kind of a bummer, but you do. I'm not this is the one that's kind of hard for me to remember. So sum of a finite geometric series. So if you just want to find, you know, if you keep adding up all these numbers, this is the formula you use. Alright? I would kind of break it down for you a little bit, but it takes a little while, and time is not on our side, which is completely my fault. But hey, let's move on. So let's find the sum of this one right here. So to find the sum, we're going to start from 1 and go all the way to 12. So the sum of 12 is going to be, well, what's the first term? Plug in a 1. What do you get? 0.3 to the 0, which is 0, so you're going to get 4. This is already in our nice little formula anyway, so that should be a 4. So it's going to be 4 times, what's R? Right, this is R, and this is A sub 1. So 1 minus 0.3 to the what power? 12. Why did I pick 12? Nobody knows why I picked 12? I just picked it? Oh, because I'm going to the 12. What do I get? I have no clue. Couldn't tell you. I'm waiting on somebody. $5.47? 5. I was gonna say that's way too high. 5.71. Okay. So at that point, just calculator. Hey, at 10, let's look at the formula here. What's A sub 1? If there's nothing in front of it, it's not 0, because 0 times that would be 0. It's going to be a 1. What's R? 2. What's N? N is 7. It starts at 1. Okay? I'm not going to go through and do this problem, but you just plug it in. Okay? We go with that. All you do is just plug it in. Y'all know how to use a calculator? Some of you are like, no. Well, then go to tutorials. Alright. Number 11. Let's write this out in summation notation first, and we'll kind of go through it. So, in summation notation, let's do n equals 1. We always start at 1. What's our formula here? So what's my first number? 7. And I'm increasing by how much each time? Times 2. So it's 2 to the n minus 1. Oh, when do I get to 896? How can I figure that out? Well, you're going to do 896 equals 7 times 2 2 to the n minus 1, and we're going to solve for n. Okay, so what do I do now? Divide by 7, you say? Okay. What do I get now when I divide by 7? Should be a nicer number. 128. Alright, this is where a lot of you are going to freak out, but you shouldn't. How the heck in the world do I solve this? Oh. So log base 2 of 128 equals n minus 1. What is log base 2 of 128? 7. So 7 equals n minus 1. What is n? Very good. 8. So the sum of the 8th term is going to be, what's my n value? I just told you. 8 times 1 minus r, which is 2, to the 8. What did I do wrong? Wait, what am I doing? Yeah, A1 is 7. Yeah, sorry. This is A1 right here. This is N, and right here is R. All over 1 minus R. Someone plug that in for me. You know, I completely forgot we're on homeroom schedule. I was like, oh, we got 10 minutes right now. Hey, I'm going to put that one on hold. You guys can do that one on your own. It's just plugging it in. Hey, last one is super easy, I promise. The easiest formula you're going to learn the entire unit. The sum of infinite series is, that's it right there. It's the first term divided by 1 minus r. So for this one right here, this is going out to infinite amount of times. Okay? It's only infinity if you're decreasing every time. If you're increasing, it's not going to work. So r has to be less than 1. So in this case, this sum is going to be the first term. All over 1 minus my r is 0.6. You would just figure that out. That's it. The key will be on Canvas at some point.